Hello everyone, this is Future Automation, a place where imagination meets reality, and you're listening to Tejas. Welcome to part 2 of Arduino, the start of IoT, a step-by-step tutorial to learning the Arduino. And today what we are going to learn is the serial communication part which we left in the last video, and we are going to create a small LED project in this video using the same serial communication concept. So with a cup of coffee, let's get started. Okay guys, so first we'll cover the small theory part again, and then we'll go to the coding part. Now, what is basically serial communication? So serial communication is a simple scheme that uses the UART on the microcontroller to communicate with it, and you can burn the code, modify the code, or get the data from the microcontroller. So basically UART is nothing but universal asynchronous receiver and transmitter. That is what. So for the 5-volt logic, what it'll do is it will transmit 5 volt for 1 and 0 volt for 0. And for the 3.3 volt, what it'll do, it will use 3 volt for 1 and 0 for the 0 volt, 0 logic. So every UART message is in form of 8 bits, that is 1 byte, where again 1 byte is equal to 8 bits. Now, on Arduino, if you'll take a look at the board, you can see that we have a chip which is basically responsible for the serial communication, transmission and receiving. And at the bottom, as I said on the last video, for the 0th and 1st pin, the, there is RX and TX which we are using for the transmission and the receiver. So if you'll check on the board, you can see here that there is RX and TX for 0th and 1. That is basically what we are using for the serial communication. But the problem is that when we are doing this with the RX and TX pins, there can be a lot of noise in the communication process, and the code that you are trying to burn will not be burned properly. There might be, failures while uploading the uh, code and all. That's why we need a USB to serial adapter, which will act as a serial port for the communication, which converts the the code into the microcontroller understandable language and burn it to the board. But that again uses the same chip, but here there will be no noise, and we'll be able to communicate with the board directly through this adapter. Now, where is this adapter in the board is, again, if we are going back to the board, you can see here at the top, we have a USB type connector, which is basically nothing but the serial connector for this board. And we have different connectors. So if you are taking node MCU, then they have added directly the micro USB connector. If we are nowadays for the Raspberry Pi, we have type C, but again Raspberry Pi is a microprocessor and not a microcontroller. But different microcontrollers are, so Raspberry Arduino Nano is having the mini USB type port, which is again like the older Nokia phones that used to have, so that type of connector. So this will make the communication with the board a bit more easier than what we have now with the RX and TX. So if we are taking the ESP8266 uh, actual board, which was launched and based on which the Node MCU and VMOS D1 Mini have been launched, that board had RX and TX communication directly. So there you have to send the AT commands to, write a logic for that board. So in future, if possible, I'll surely show that board to you guys, and I'll show how the AT commands were used to program that board. Now, moving on. So this is the coding part, and we are going to move to the coding part now. So let's go to the Arduino IDE, and I have already connected the board. So this is the board that I have connected to my computer. The board is selected and the port is also selected here. So for COM3, and the board is Arduino Uno. Now let's start with the serial communication, and don't worry again about the code. I'll be adding code into my GitHub repository, and you can check it out. You can pull the repository and you can start working with Arduino. Also, I'll try to add the documentation as well in the README file and this presentation so that you can refer it while working on the Arduino projects. Now, in serial communication, so going back to the presentation, once I'll quickly cover it up. So in serial communication, the first two things that are very important is serial begin. So what serial begin does is it initiates the serial communication with the board, and now serial begin can be written in two different formats. So one is speed and one is speed and config. So we have either one parameter or we have two parameters. Usually we are using the only first one, which is serial begin, with speed as a parameter and not the speed with configuration. Now speed here represents the baud rate in which we are sending the data or receiving the data, which will be bits in bits per second. So we have 9600 bps, we have 4800, we have 14400, we have 38400, we have 28800, and then we have, I think, 5400, 54400, something like that. So we have different baud rates. Now you need to make sure that you are setting the baud rate here correctly, and the same baud rate is selected in the serial monitor again that I'll show you in a minute while writing out the code. And then this part is done in void setup. So we are doing this only once by to initiate the serial communication, and then in the loop we are going to communicate with the board using the serial print and serial read and all that. Now here I have given all the three main concepts and its details. So one is serial, it signifies the serial port object. Speed, it signifies the baud rate or BPS rate. It allows long data types. So basically, you can also send the strings through the serial communication as well. So if there is a string you need to concatenate with one of the data, then that will also be taken care of by this speed related parameter. And then in config, it sets the stop priority and data bits. So there are different bits that you can set to perform different actions. That is done by this config parameter. Although I've never used this config parameter, we are only going to use the speed one. Now, here is a small example of how we can write the serial begin code. So let's write it. Yeah, here we are going to do a serial dot begin, and then here we are going to write 9600. Now, mostly there are two baud rates that are very famous. One is 9600, and then there is one more which is uh 54400, something like that. I'll show you. So there is an option here where we can select the baud rate. Let's see if they have kept it here or they have changed it. So it's getting tools. Okay, I think we have directly added it in the serial monitor only. So if we are opening the serial monitor, then at the bottom you can see, once again we need to select the board. Six, I think. So usually if we are connecting the board to a different port, then we need to uh, select the right COM port, or the serial monitor will give an error. So you can see at the right corner here, you can see the baud rates. So there are different baud rates in which we are communicating with the board. One is 9600, that is very common, and then we have 11.5 200. So this is the another one which is very common next to 9600. So you need to keep in mind that the baud rate you are providing here should be the same baud rate that you are adding in the serial monitor, or you won't be able to see the correct message. So moving on back to the presentation again. So in the next slide, what we are having, so serial print. Basically serial print is nothing but it is going to print the data which we are sending from here in the serial monitor, that is from the board. So now you try to understand this, that the serial monitor that we are showing here is basically the monitor from the board. So whatever you are going to see here will be written from the board side. So see, for example, if we are trying to write a data that is coming in from the sensor on the serial monitor, so that time we are using this function called serial print. We have serial print ln as well, which will print every time on the next line. That is what we are having. Now we have again two different ways to write it. One is serial print with value, or serial print with value with format. So if you want to, write the current data in a different format, then you can use this. But again, it depends on the use case that you are writing. Now going back to the code, we'll write it here. So serial dot print, and then here whatever data you want to write. So hello hello world world, and then semicolon. Now, the basic serial communication code is this much only. But there is one main important thing that you need to know about serial communication, is that how to write data. Now we are understanding how to read the data from the serial communication, but how to write the data if we want to write the data to the board. Say for example, we have created a project that we are going to create now. We have two LEDs, and when I'm going to send one, it should turn on one LED, and then when I'm going to send two, it should turn on the second LED, and when I'm going to press 3, it should turn off both the LEDs. So that time you need to know how to communicate with the serial board to get read the data. So going back to the presentation again, you have one thing that is serial available and serial read. Now to use serial read, you need to know how to use serial available as well. What serial available is doing, it is checking if there is some data available from your end or not. So if there is an available data from your side, then it will go in the uh, in the code block, and it will check what is that data, and then it will print that data if you want, or you can again perform different functions in that. So that is how serial available works. Okay, so let's go back to the code and start working on the serial available. We'll write that code as well here. So if serial dot available, and then this, you can see that we are having the code complete functionality here, and that's really great. So they have came a long way developing the IDE and making it very powerful. So x is equal to serial dot read. Now in read also we have different functions, read bytes and all that. So you can use based on the use case that you are having. Serial dot print. See, you can see here we have print ln as well, and x, and yep, that's it. So if I'll put a delay, so I think don't need to put here delay. And yeah, that's the code for serial communication. Now you can see that it's pretty simple. If you will count the line of codes in excluding the setup and loop, 1, 2, 3, 4, 5, 6, 7, 8. So 8 lines of code, and we are good in serial communication. So let's upload the code and see if it works. And I'm uploading the code now, and uploading is done. So if we'll go to serial monitor, I'll clear the output one more time, and you can see it is printing hello world. So let's give it a bit of delay, or we will remove this hello world again, and we'll upload the code one more time. We'll clear the output, and now we can enter anything and see if it prints. So you can see here, I sent a message to Arduino Uno, and it has printed me back the same thing. So That is how the serial communication works. Now you know the basic idea on how it is working. So I'll suggest you, if you have an Arduino and if you have few LEDs, you can go ahead and try to create the project that I mentioned previously, which is if you'll press 1, then it should turn on one LED. If you'll press 2, it should turn on second LED. So in the meantime, you can pause the video and you can do it.
One eternity later.
And for those who are new, let's go to the project and we'll start creating that project. So for the presentation perspective, we are almost done. There is nothing much to explain about the serial communication. So thank you for that presentation, and all. Thank you guys for the previous video support. It was really great. It was really fun. So I'm adding both the presentations in the Git, and you can check the code and the presentations out. Let's move to the Arduino now. Okay, guys. So till now what we did was we tried to communicate serially with the Arduino board, and now what we are going to do is we are going to implement the same concept with a small project that I have created. Don't worry about the code, don't worry about the connection of the board, because that part will be covered in the next videos. For now you just need to understand how communicating serially with the board can help you in a lot of projects. So at one side you can see we are having the board ready, and on one side we are having the pin diagram. So let me give you a quick overview of how exactly we are planning to do it. Although the pin diagram is only related to one LED, but we are going to connect two LEDs in this. And what we are going to do is we are going to send some data from the serial communication to board, and based on that data it will decide which LED to turn on. So basic idea for this is that we are having one LED and one more LED will be having here. So both will be connected to one to 13th pin and one to 12th pin. And then what we'll be doing is we'll be passing in some data to Arduino board through our computer, which will be 1 and 2 and 3. So what we'll do is it will, for 1 it will turn on one LED, for 2 it will turn on another LED and it will turn off this one, and for the 1 it will be turning off this one, and for 3 it will turn off both the LEDs. So that is what the basic idea to create this project is. So let's get back to the board and see what all things we'll be needing in this project. So now for hardware part, what we'll be needing is, one, we'll be needing this Arduino board, and another thing that we'll be needing is a breadboard, two LEDs. Now you can see here, let me try to zoom in a bit more to see if we can see the LEDs as well. So you can see here that we have connected two LEDs and the connection is already done, because I don't want it to waste much time on this connection, because we are going to cover that how the breadboard works, how to connect LEDs, what are the different properties of it, which pin we need to connect to which pin of the board, what are pinout diagrams, how they are useful to us in any project. We are going to discuss in coming videos. For now, all you need to understand is how serial communication impacts each and every project, and how you can use that to create a simulation of the data that will be passing to the Arduino board, and to make sure that the project is working or not. Let's move to the connection part now. Okay, guys, so we have completed the connection, and now let's go back to the coding part. So by the time we left the last code, we were here. We were trying to get some data from computer to the serial communicator board, and from there we were trying to print it back again. Now most of the code will remain same. We are just going to remove the printing part, and what we are going to do is we are going to write an if else code here. So for those who are from the programming background, for them if else is pretty similar to what we are doing till now. It's almost C only. And for those who are new, you don't have to worry, because if else is a pretty similar concept. We are having conditional blocks of code, and in that we are performing different action based on the condition that is being satisfied. So if we have x, which is equal to now this is a char, so 1, I think we'll have to do it in double quotes only. Yep, 1. And then what we'll be having is digital, right? And then the code part. Before that, let's copy this because we are going to need it one more time and paste it. So digital write, and yeah, we need to, before writing down this function, we are just creating a basic structure of the code. We still need to add the pinouts and the pin modes. Sorry, the pin modes, not the pinouts. Else if for 2, and then the else part, which will be again copy and paste. Now the basic structure of the code is set, and now what we need to do is, as we have seen in the previous video, we need to set out some variables to for the pins of the LED that they are connected to. So LED 13 will be 13, then int LED 12 will be 12, and then we are going to set the pin modes here. So pin mode LED 13 will be output, and again pin mode LED 12 will be output. Okay, so we are done. Now what we need to do is we need to just set out the values. So for 1, what we'll be doing is we'll be putting out the LED 13 to high and LED 12 to low. So LED 13 to high and LED 12 to low. Now in 2, what we are going to do is we are going to do similar, but we are going to do it inverse. What we'll be doing is we'll be setting off the LED 13 to low and LED 12 to high. And here at the bottom, for both, we'll be setting up low. And yeah, that's it. So this is what we are going to do. But here again, there is one more thing that I can do is else if, and then 3 x equal to 3, because it will then again blink a bit faster and will not be able to identify whether it is working or not. So let's see if the code is correct and either it is working or not. I'm dimming out the light a bit, and let's see if okay, as of now both are off. And if we'll clear out the serial monitor and see if we can send 1 and everything is working.
It was at this moment that he knew. He fucked up.
Okay guys, so before moving on, there was one small mistake that I did. That is, you need to add the data that is to be verified in single quotes and not in double quotes, since it is in char. So that was one mistake that I did in the previous compilation, and because of that, the code was not working. So I had to take a pause and check what was the issue. So that was basically the issue, and everything else is same what we are doing. So let's compile one more time and make sure you are keeping an eye on the LEDs. So let's do it. Now in the serial monitor, you can see if I'm pressing 1 and putting it out, the first LED, this one is blinking, turning on. So I'll just bring down the light a bit so that you can see it. If I'm putting 2, that will turn off, and the second LED, which is the back one, is again blinking now. So I know both are of same color, but I had those two only. Okay, so next to that, if I'm putting 3, both will turn off. So that is what it is. Now you can see that you can create what kind of projects using serial communication. In coming videos, there is a video where we are going to deal with the LCD, 16 cross to LCD, where we'll be using serial communication again to put data in LCD, and then we are going to create one more small project where we are going to show YouTube stats and Instagram stats on that LCD. We'll try to do that. I have done it once before, but again, a lot of security changes keep on going. But with YouTube we can do it because we'll have the YouTube API, and we can use that API to get the data and show it on the LCD, so that we can do. And for now, this is it, guys. We were interested in the serial communication, and we were only going to focus on that for now. Don't worry about the code, don't worry about the whole connection of the LEDs to the board and all. That will be covered in the next video. For next video, I have planned to do the analog read first, which will and analog write, which will again be useful in some of the sensor projects. So that will be covered. And then again, we are going to do a small LED project where we are going to use analog values to see if we can control the brightness of the LED. So that's it, guys, for today. If you like the video, make sure you hit the subscribe button, and thank you everyone for making the 1K plus milestone successful. This is all because of your views and your comments and your love for my channel. So keep liking videos and checking out all the videos and sharing them with others. If you have anything, make sure you add them in the comment box. If you have any ideas as well, make sure you hit them in the comment box. Share it with all the IoT and all the electronic enthusiasts. Also check out my previous podcasts. There are more upcoming. So make sure you subscribe to my channel and hit the bell icon, and keep innovating, guys. Thank you. Take care.